Welcome back, Honors Algebra 2. We are continuing on with the Chapter 1 study guide, and we are picking up with number 11. So it asks you to simplify. If you notice, you have an I in the denominator. And remember, when you do have an I in the denominator, your goal is to essentially get rid of the I in the denominator. And so we do that by multiplying it by its conjugate. So its conjugate is just essentially the same thing, 4 minus 3i, but just the opposite operation in between. So we're going to multiply the top by 4 plus 3i and the bottom by, again, 4 plus 3i. So we're multiplying it by a factor of 1, so it's keeping it the same fraction still. So we just have to multiply. We take our time, make sure we're multiplying correctly. 6 times 4 is 24. 6 times 3i is 18i. 5i times 4 is 20i. And then 5i times 3i is 15i squared. And then all divided by 4 times 4, which is 16. 4 times 3i, which is 12i. Negative 3i times 4, which is negative 12i. And negative 3i times 3i, which is negative 9i squared. So then we, of course, go through and simplify. I know that anything, wherever I see an I squared, that's negative 1. So this whole thing is going to be negative 15. And then same with here. This is really saying negative 9 times negative 1, which is positive 9. And then remember, your goal is to get rid of the i's in the denominator. So did we do that? 12i minus 12i is 0. And so I did. So what happens is I simplify. So 24 minus 15, because that's 15 times negative 1, gets me 9. 18i plus 20i can combine to get me 38i. And then 16 plus 9 gets me 25. Now I look between 9, 38, and 25. Is there anything that I can simplify between all three of those? And there isn't. So that is my final answer. 9 plus 38i, all divided by 25. And remember, when you guys are writing something that has an imaginary portion, you always put the real part first and the imaginary portion second. So that's why this order is important, 9 plus 38i, instead of flipped around 38i plus 9. Okay, so now number 12 says solve in the complex number system. Use the best method to solve. So remember, whenever you guys have an x squared or quadratic, like you do for number 12, the first thing you should be thinking about doing is setting the entire equation equal to 0. That way you can always factor or use the quadratic formula, whichever method, but you always want to make sure you move it over and set it equal to 0. So I'm going to subtract 2x, and that gives me 2x squared minus 2x plus 1 equals 0. Now, I always like to see first if I can factor, and so I'm thinking what two numbers multiply together to get me 2 and add to get me negative 2. And I don't know any numbers, and so what I would do is I would then plug it into the quadratic formula. So x equals the opposite of b, so the opposite of negative 2 is positive 2. Plus or minus the square root of negative 2 squared minus 4ac, all divided by 2a. And then I just simplify so that I use my calculator. That's 4 squared minus 8. Or I'm sorry, 2 squared, which is 4, minus 8, which is negative 4. And then 2 times 2 is 4. So I can, of course, simplify this. I know the square root of negative 4. Well, first I know the square root of negative 1 is I, and I know the square root of 4 is 2. So this can simplify to be x equals 2 plus or minus 2i all over 4. Now I think, can I simplify it? Do I know, is there a number that goes evenly into 2, 2, and 4? And there is. 2 goes evenly into all of those. 2 divided by 2 is 1. 2 divided by 2i is 1i. And 4 divided by 2 is 2. So my final answer is x equals 1 plus or minus I over 2. And that does it for 12. So let's move on to number 13. Again, solving the complex number system, use the best method to solve. So first off, I'm looking at it and I'm thinking, is my equation set equal to 0? And it's not. And so before I can do anything, I want this set equal to 0. So before I actually move the 6 over, I am going to multiply this x out. And so that's going to get me x minus x squared equals 6. So now what I'm going to do, now I'm going to move everything over so it is set equal to 0. Now I prefer to always have my x squareds be positive, so I'm going to move everything over to the right-hand side. I'm going to add x squared over here, and I'm going to subtract x on this side as well. So my equation is going to be 0 equals x squared minus x plus 6. So I'm thinking, do I know two numbers that multiply together to get me positive 6 and add to get me negative 1? And I don't. I know a lot of you guys are thinking, what about 3 and negative 2 or negative 3 and 2? But that would multiply together to get me negative 6, not positive 6. So again, if I can't factor it, I'm going to use the quadratic formula. So x equals the opposite of b, so positive 1, plus or minus the square root of b squared minus 4ac, all divided by 2a. So negative 1 squared is 1 minus 4 times 6, which is minus 24. So this is going to be x equals 1 plus or minus negative 23 all over 2. Now, I know we can't simplify 23, but we can simplify the negative inside the square root. Whenever you guys have a negative inside the square root, you can always factor that out and have I rad 23 over 2. So I look to see, is there anything I can simplify? Is there anything that goes evenly into 1, 1, and 2? And there isn't, so that's our final answer. X equals 1 plus or minus I rad 23, all divided by 2. Okay, let's keep going. Okay, so we are continuing to solve. Again, first step, I noticed that not everything is on one side of the quadratic. So what I'm going to do is I'm going to move everything over. I'm going to move everything over to this side. And so I'm going to subtract 2x, and I'm also going to subtract 3. So that's going to give me 4x squared minus 2x minus 3 equals 0. So I, of course, like to first see, can I factor this? Do I know two numbers that multiply together to get me 4 times negative 3, which is negative 12, and then adds to get me negative 2? And unfortunately, I don't. So again, I'm going to have to use the quadratic formula. So that is the opposite of b plus or minus b squared minus 4 times a times c, all divided by 2a. So I'm going to use my calculator for that. So that's going to be 4. And then this minus and minus is going to become a plus. So we're going to be adding. So it's really 4 plus 4 times 3, which gets me 52 inside the square root. And then in the denominator, 2 times 4, which is 8. So then I can break up 52. I'm always thinking, like, is there a perfect square that I can break it up into? And there is. I know that 4 goes evenly into 52 and 4 times 13. So I can take out the 4 because we know the square root of 4. And so that would get me x equals 2 plus or minus 2 rad 13 all over 8. Now, I always want to check to see if I can simplify that. So I'm looking to see, is there a number that goes evenly into 2, 2, and 8? And there is. 2 goes evenly into all three of those numbers. So I can simplify. 2 divided by 2 is 1. 2 divided by 2 is 1. And 8 divided by 2 is 4. So my final answer here is 1 plus or minus rad 13, all divided by 4. You don't need to put that extra 1 there and when it's in front of a radical. Okay, so number 15, it says without solving, determine how many solutions the quadratic will have. Hint, use the discriminant. So all that we have to do is determine how many solutions the quadratic will have. We don't have to figure out what the solutions are going to be, so we just have to figure out the discriminant. Remember, the discriminant is b squared minus 4ac. So I'm going to just plug in my values. B squared, so 2 squared, minus 4 times a, which is 1, times c, which is negative 8. So that's going to be 4 minus 4 times negative 8, which is negative 32. That's going to be added together. And 4 plus 32 gets me a positive 36. So when I have a positive discriminant, remember, a positive discriminant means that I'm going to have 2 real solutions. So that is my answer. So 16 is the exact same question. It's asking you again, find the discriminant and determine how many solutions the quadratic will have. So again, we're using the same formula. B squared, so negative 10 squared, minus 4 times a, which is 1, times c, which is 25. Negative 10 squared is 100. 4 times 25 is 100. And so 100 minus 100 is 0. When I have a 0 in my discriminant as my discriminant, remember, a 0 discriminant means there is 1 real solution. So the only thing we didn't cover here was a negative discriminant. When you have a negative discriminant, remember that's 2 complex or imaginary solutions. Okay, let's continue on. So number 17 says solve in the real number system, and we have x to the 4th minus 26x squared plus 25 equals 0. So what we're going to do is we are going to use u substitution here. Remember with this one, we're really thinking about this is really similar to x squared minus 26x plus 25. And so we can rewrite this as x squared squared. Oops, I didn't put the square in there. Let's white it out and make that clearer. So x squared squared, because x squared squared is x to the 4th, minus 26x squared plus 25 equals 0. So like we did in the notes, we're going to use u substitution here. So we're going to let u be equal to x squared, and I'm going to substitute in a u here and a u here. So that's going to be u squared minus 26u plus 25 equals 0. So now I can factor. So I'm thinking what 2 numbers multiply together to get me 25 and add to get me negative 26. And that's going to be negative 25 and negative 1. Negative 25 plus negative 1 is negative 26. Negative 25 times negative 1 is positive 25. So I first start by solving for u. So u minus 25 equals 0, and u minus 1 equals 0. And then add 25, and I get u equals 25, and u equals 1. Now that I've gotten u all by itself, I can go back in and substitute back in x squared and solve for x. Because remember, our goal here is to solve for x. So I'm going to move this both over here. So that's going to be, instead of u, we're going to substitute back in x squared equals 25. And then same with here. Instead of u, we're going to substitute back in x squared equals 1. So then to solve for x, all we have to do is square root both sides. I get x equals plus or minus 5. Do the same over here, square root both sides, and I get x equals plus or minus 1. And so I have 4 solutions here. I have 5, -5, 1, and -1. And that's it. And there are other ways that you guys can do that. You can like actually factor that and just think about it as x squared minus 25 times x squared minus 1. That would work too. But U substitution is something that we went over in the notes. So it was something I wanted to continue doing here. Okay, so our next problem, again, we're going to be using U substitution. So I have 2x plus 1 squared plus 13x plus 1 plus 15. So I'm looking, what am I going to substitute U for? And I'm going to let U be equal to x plus 1. So I'm going to substitute in a U here, and I'm going to substitute in a U here. And so that's going to be 2U squared plus 13U plus 15 equals 0. So I'm going to see if I can factor that. Do I know 2 numbers that multiply together to get me 30 and add to get me 13? And I do. That would be 10 and 3. So I can actually split the middle term here. Remember, we have to split the middle term here compared to here because A is greater than 1, where here A is equal to 1. So we would do 2U squared plus 10U plus 3U plus 15. Now that I have 4 terms, I can factor by grouping. So from 2U squared plus 10U, I can factor out a 2U, and I'm left with U plus 5. And then from 3U plus 15, I can factor out a positive 3, and I'm again left with U plus 5. So now I always want to double check, are these the same, which they are. And so now I can write it factored. 2U plus 3 times U plus 5 equals 0. And so now I can set these both equal to 0 and solve for U. So 2U plus 3 equals 0 and U plus 5 equals 0. So subtract 3, divide by 2, and I get U equals -3/2. And then here, a lot more easier, subtract 5, I get U equals -5. Now remember, our whole goal here is to solve for x. So I've only solved for U at this point. I'm going to substitute back in x plus 1 for U in both of these spots. So it's going to be x plus 1 equals -3/2, and then x plus 1 equals -5. And then I just solve. So I'm just going to do that in my calculator. I'm going to do -3/2 minus 1, because I've got to get x by itself, and then write it as a fraction, so -5/2. So x equals -5/2, and then do the same over here. So get x by itself by subtracting 1 from both sides, and I get x equals -6. So my 2 solutions, -5/2 and -6. And that's it. Okay, so those were our 2 U substitution. Let's move on to our radical equations. So number 19 says solve in the real number system, and remember to check your answers. So remember, when it tells you to check your answers, you've got to check your answers. So first thing I'm going to do is I'm going to first isolate. Remember, we're isolating the square root expression. So we're isolating this rad 4x minus 1. And so that means I need to subtract the 9 from both sides. And I have the square root of 4x minus 1 equals -4. But wait, what do we know a square root has to be equal to? Well, the square root of anything always should be equal to a positive number. And so this one, we can stop right here. This one is going to be no real solutions. So whenever you have a square root equal to a negative number like that, you can assume, you can stop the problem. You don't have to continue solving. And it's at that point where it's no real solution. And so that would be your final answer. Okay, let's move on to 20. So for number 20, similar type of problem. you first, just like you did on the last one, you want to isolate the square root expression. So that would be rad 12x plus 28. So that means the first thing I want to do is I want to add x to both sides of this equation. So I have, I'm actually going to write it over here, the square root of 12x plus 28 equals x plus 4. So now that I've gotten the square root expression all by itself, now I can start to undo that. So I'm going to square both sides. So remember, when we're squaring a square root, that's actually going to get rid of it completely. And so I'm going to be left with 12x plus 28. And then remember, when we're squaring an expression like this, like x plus 4, we have to expand that and multiply. So it's x plus 4 times x plus 4. And so we multiply that out and distribute. So that would be x times x, which is x squared, x times 4, which is 4x, and then 4x, so 8x, plus 16. So because we have an x squared, that means we do have to get everything to one side of the equation. So that means I'm going to get everything to the side with the x squared. So I'm going to subtract 12x from both sides. And then I'm going to subtract 28 from both sides as well. So I have x squared. 8 minus 12 is negative 4x, and 16 minus 28 gets me negative 12 equals 0. So then I look to see, can I factor that? Do I know two numbers that multiply together to get me negative 12 and add to get me negative 4? And I do. And that would be negative 6 and positive 2. Now that it's completely factored, I can set each factor equal to 0 and solve for x. So add 6 to both sides, I get x equals 6. Subtract 2 from both sides, and I get x equals negative 2. Now remember, we do have to check our answers. So to check our answers, I'm just going to plug those in over here. I'm going to plug it in at this point once we've isolated the absolute value or the square root expression. I don't know why I keep doing that. I did that in notes too. So let's check with 6. So 12 times 6 plus 28 equals 6 plus 4. So 12 times 6 is 72, plus 28 is 100, and 6 plus 4 is 10. That makes sense. Works out. We're going to also do it with negative 2. 12 times negative 2 plus 28 equals negative 2 plus 4. That's negative 24 plus 28 is square root of 4 equals 2, which makes sense. That works. So both of these are my solutions. So my answer is 6 and negative 2. Okay, so then we're going to continue on. 3 more problems to go. So 21 says solve in the real number system. Remember to check your answers. So remember, with a double radical, just take your time, check your work. You can do this. So first thing I would do is look to see which one of these two is a little bit more challenging. And the one that would be more challenging would be this one. So that's going to be the one that I isolate first. So I'm going to add the square root of x plus 2 to both sides. And then I am going to put my work over here. So I have the square root of 3x plus 10 equals 2 plus rad x plus 2. So now that this one is isolated, the square root expression is isolated, I can square both sides. So when we square a square root, that becomes 3x plus 10. And then remember, with this one, we do have to expand and multiply. So it's 2 plus rad x plus 2 times 2 plus rad x plus 2. So really here is the point where you've got to just take your time and slow it down and check your work. So 2 times 2 is 4. 2 times rad x plus 2 is 2 rad x plus 2. Rad x plus 2 times 2 is 2 rad x plus 2. And rad x plus 2 times rad x plus 2 is x plus 2. Gets rid of the square root altogether. So then I just start to combine my like terms. So I can combine 4 with 2, and I can combine also 2 rad x plus 2 and 2 rad x plus 2. So I have 3x plus 10 equals x plus 4 plus 2, which is 6, plus, and with this, because of they're like radicals, we just add the coefficients. So 4 rad x plus 2. So then, now that I've gotten one square root, now my goal is to isolate that. So I'm just going to subtract x and subtract 6 and start isolating the square root over here. So 3x minus x is 2x, and 10 minus 6 is 4, and then 4 rad x plus 2. Now at this point, you can divide both sides by 4, but you'd have a fraction, and I don't want to deal with fractions. So because this is multiplying, we can square both sides and undo that square root. So what happens, again, here we're going to have to expand and multiply. So 2x plus 4 times 2x plus 4. And what happens here is it's really just 4 rad x plus 2 times 4 rad x plus 2. So the 4 is squared, and then the rad x plus 2 is squared. And we're just left with 16 times x plus 2. So then we need to multiply it out. So 2x times 2x is 4x squared. 2x times 4 is 8x, plus another 8x is 16x. And then 4 times 4 is 16. And then distribute here, so 16x plus 32. Once I recognize that I have an x squared here, I do need to move everything over to one side of the equation. So I'm going to subtract the 16x, and I'm going to subtract the 32, because I'm going to move everything over to the same side as the x squared. And so what I'm going to be left with is 4x squared. 16x minus 16x cancels, which is great. And then 16 minus 32 is negative 16 equals 0. And so now I can either solve it by factoring, or I can actually solve it by just isolating the x squared. I can add 16 to both sides, divide both sides by 4, and then to undo the squaring, I'm just going to square root both sides, and I get x equals plus or minus 2. So remember, with these, you do have to check your work just like we did up here. I'm just going to mentally check them. So I'm going to plug it in. So that's going to be, so mentally we can just check it. Sorry, Miss Curry came in to interrupt the video. So honestly, let's just plug it in. It's probably easier. So it'd be 3 times 2 plus 10 minus 2 plus 2 equals 2. So that's rad 16, which is 4, minus rad 4, which is 2, which makes sense. Let's try it with negative 2. 3 times negative 2 plus 10 minus negative 2 plus 2. That's negative 6 plus 10, which is 4. Square root of 4 is 2. Negative 2 plus 2 is 0. Square root of 0 is 0. Makes sense. So those are both of my solutions. X equals plus or minus 2. And that does it. So again, check your work, take your time. You can do these. Okay, so we're going to continue on with number 22. Number 22 is one of our word problems. So first thing, whenever you're doing a word problem, just read the entire problem. So Steve, a recent retiree, requires $5,000 per year in extra income. He has $70,000 to invest and can invest in bonds paying 8% per year, or in a certificate of deposit paying 5% per year. How much money should be invested in each to realize exactly $5,000 in interest paid? So first thing I do is I look to see what is it asking me to find. And it's asking me to find basically how much money should I invest in both the bonds and in the CDs. Okay, full disclosure, I just paused for a very long time because I had to hop onto class. So I'm coming back to 22, and we just talked about the question and what it's asking us to find, which is how much money should be invested in both, in each, right? So I'm going to put X is going to be my bonds, and Y is going to be my CDs. So the amount of money in bonds and then the amount of money in CDs. Now, then we kind of pull out what else is important information. It's important that Steve wants to get a total of $5,000 per year in extra income, which he's going to be earning that extra income by interest. And then he has a total of $70,000 to invest. So those are really important too. So the total dollar amount that he has is going to be $70,000, and then the total interest, because that's how you're earning an income when you're like when you have a stock or something. The total interest is going to be $5,000. So whenever you have two variables like that, what we're going to do is we are going to write two equations. One of them equaling 70,000 and one of them equaling 5,000. So the one that's going to be equal to 70,000 is basically the total dollar amount that you have for the bonds plus the total dollar amount that you have for the CDs equals my total dollar amount. So that's X plus Y equals 70,000. Now with the interest, that's when we involve the interest percentages. So it's 8% for bonds and it's 5% for CDs. So it's the interest rate times the dollar amount, so 0.08x, plus the interest rate times the dollar amount, so 0.05y, equals the total interest rate. So now that I have my two equations, I can solve by either using substitution or elimination. So I'm going to use substitution. I'm just going to take this one and I'm going to solve for y. So that means I'm going to subtract x, and I'm going to have y equals 70,000 minus x. And so now I'm just going to substitute. So I have y equals this. So I'm going to substitute that in 70,000 minus x in for here. And so I have 0.08x plus 0.05. Multiply that. 70,000 minus x equals 5,000. So from there, I'm just going to distribute the 0.05. So I'm going to use my calculator. So 0.05 times 70,000. Which is 3,500 minus 0.05x. And I should mention, we could have solved for x up here. It doesn't matter. Then I combine my like terms. So 0.08 minus 0.005, which is 0.003x. Subtract 3,500 from 5,000, which is 1,500. And divide both sides by 3%. And I get x is equal to 50,000. So it is asking us for both. We did get the amount in bonds, so now we need to get the amount in CDs. So I'm just going to plug that in here. Y equals, excuse me, 70,000 minus 50,000, which gets me 20,000. So that means there's 50,000 in bonds and 20,000 in CDs. And that does it for 22. Okay, so let's move on to 23. Very similar to 22. A coffee manufacturer wants to market a new blend of coffee that sells for $3.10 per pound by mixing two coffees that sell for $2.50 and $4 per pound, respectively. What amounts of each coffee should be blended to obtain the desired mixture? Assume that the total weight of the desired blend is 50 pounds. So first, we're figuring out what is it asking us to find. And it's asking us to find what amounts of each coffee should be blended to obtain the desired mixture. So I'm going to put X is the pounds of the 250 coffee. And Y is going to be pounds of the $4 coffee. And then I start to pull out any important information. First is my total weight of the coffee, or the new blend, is going to be 50 pounds. And then the other important thing is that they want to sell it for $3.10 per pound. So total pounds, my pen's running out, is 50. Now the total dollar amount is not just $3.10. It's $3.10 per pound. So if we're selling 50 pounds, it's going to be $3.10 times 50, which gets me 155. So again, we have two variables, which means we're going to have two equations. One that's equal to the total amount of pounds, one that's equal to the total dollar amount. So total pounds is just going to be the pounds of the coffee plus the other pounds of the coffee equals the total pounds. So X plus Y equals 50. And then the total dollar amount is going to be the dollar amount times the pounds plus the dollar amount times the pounds equals total dollar amount. So 250X plus 4Y equals 155. And now I'm at a really similar spot that I was up here. I'm just going to solve for one of my variables before I solve for Y. So I'm just going to solve for X and show you that it really doesn't matter. So X is equal to 50 minus Y. I'm going to use substitution. So if X is equal to 50 minus Y, I'm going to substitute that in here. So 250 times 50 minus Y plus 4Y equals 155. So then 250 times 50 is 125 minus 2.5y plus 4y equals 155. Combine my like terms, so negative 2.5 plus 4 is 1.5. Subtract 125 from both sides. And then divide both sides by 1.5. And I get y equals 20. So from there, what I'm going to do, I have y. Now I'm just going to solve for x. So x is equal to 50 minus 20. 50 minus 20 is 30. So that means I have 30 pounds, of the 250 coffee. And then I have 20 pounds of the $4 coffee. And that does it for the study guide. So remember, make sure you guys are bringing questions to class so we can go over them as a group. And then if you guys need anything else, just always email me and let me know. Hope you guys have a great day, and I will see you guys soon. Bye, guys.